right, one last example. Let's take a look at our network file system. We do a show mount on our Linux. We see we have export Georgia. A couple of our vulnerability scanners found this. It is available to everyone. Typically, you'd probably see it just available to a certain network, but since I hand out this VM, and who knows what your home network IP addresses are, or the IP addresses at the classroom I'm at, we just put it as star here, so it's available to everybody. So we have to figure out how to mount it, so this is something you may Google as well, because the syntax for mount can be a little bit complicated. Let's see if I can remember. Mount -T for type, network file system, and then we want IP address we want to attach to, and then we want a colon, and then export Georgia, and then we need where we want to put it, which I didn't create a mount point for it, so let's make one first. So make dir temp Georgia, and then we want mount type NFS, and 192.168.1.80 colon export Georgia, and put it at temp Georgia. And it's going to complain and say RPC stat isn't running, but then it tells us we can use -O no lock to fix it. So long live error messages that make sense. So that should mount just fine. So we can go into temp Georgia, and again, this syntax here is of course in the slides, so all of our syntax is, so don't worry about reading it off the video. We go to temp Georgia. We actually copied this credit cards.txt over in our previous example, and these are IDRSA.pub and IDRSA you shouldn't have. I used this VM as a target in like a lab exercise in a class I was running for someone a couple weeks ago, and somebody obviously didn't get the exercise quite correct, so yours probably doesn't have those. But if we do that ls-a, that'll show us our hidden directories, and we noted in vulnerability scanning that the .ssh directory might be interesting because that's where we keep our keys. So we have a couple of ways we can do this. Since we have write access, we can actually create a key and add it to this authorized keys file. So we cat that out. Currently there's just this one, but we can actually add another. Or what we can do is copy Georgia's private, which is this one, and public keys. So that's what we'll do. So I want to put it in root.ssh, so in my .ssh directory. Cannot create regular file, root.ssh. Do I not have a .ssh directory on this version of Kali? Surely I do. Apparently not. apt-get install open SSH server. So that's already installed. Okay. That's rather odd. Let's see if it'll just let me do this. What if it has SSH add? It does have SSH add, so I should just be able to create one. This is odd. There's definitely one on earlier versions of Kali. This is what I get for upgrading to a newer version of Kali for our videos. So I'll just create the .ssh directory and then copy this over. Same thing with .pub. So there. Now if I do an SSH add, it'll add my identity into SSH, so that's my key now. So we stole Georgia's key, and now that's our key. So what'll happen if we try and log in as the user Georgia at Linuxbox, instead of prompting us for a password, the first thing it's going to do is check and see if we have the correct key. And sure enough, we do. We have the key that's on that authorized keys list. So we're actually able to bypass password authentication. So we're only a regular user. Georgia is a sudoer, but not having Georgia's password, we're not going to be able to sudo as Georgia. But we do have a certain level of access here, certainly pretty good. So in our post-exploitation, we'll see about turning this and some of our other low-privileged accesses into complete control of the systems. But first, let's take a look at some password attacks.